Hi everyone, and welcome to Say Cheese. My name is Jolanda Verhoef, and I'm a developer relations engineer at Google. And today I want to talk about how you can elevate your camera flows using Jetpack Compose. So when you're implementing a camera feature, there are many questions that might pop up. For example, is there maybe a ready-made solution that you could be using, or do you have to develop everything yourself? Should you be using camera X or camera 2? And should you be using views or compose? Well, for that last one, I'm gonna quickly give you an answer. Obviously a no-brainer. Jetpack Compose is the future of UI development. I'm a big fan. I'm in the Compose developer relations team at Google. So of course, today I'm gonna do everything using Jetpack Compose. So before we dive into these questions and how to answer the other ones, let's look at some examples of what we actually use the camera for. Like, we all have a magical device in our pocket, and we use it for a lot of different things. The first one that comes to mind is capturing an image or taking a video using the system camera. So here I'm showing my Pixel, which is taking a picture of a beautiful lamp. I don't know why a lamp. It's very boring. Most logical thing you could be doing. But of course, that's not the only thing we can do with a camera. We can also hop on a video call. So if we're not at home, if we don't use our fancy webcam on our laptop, we can actually use the camera in our phone, the front-facing camera typically, to show ourselves and add some effects to it as well. Here I'm on a great beach with a mustache, which both of those I don't actually have in my normal day-to-day life. But this actually, works out of the box when you buy a phone, in this case with Google Meet. Another thing we can do nowadays, and which a lot of people do with their phones, is uploading stuff to social media. So they record a video, either of themselves or of someone else, again, add effects maybe, or do something funny with it, or make themselves look prettier than they actually are. Lots of different requirements all built into apps. In this case, I'm uploading a YouTube short, but yeah, there's multiple social media apps that do this kind of things, and it's actually extremely powerful. However, we don't actually have to capture what we're filming or what we're seeing. We can actually use the camera sensor's content to have a useful experience by just taking a look at the preview stream. So in this case, I'm using Google Translate, because I was on a holiday and I wanted to cook some rice, because that's what you do on a holiday. And I wanted to live translate the conditions of how to do that. Works with Google Translate directly. Another powerful thing that you can be doing nowadays is to scan a document. So you don't need to have that physical scanner at home anymore that's built into your printer or all that very difficult stuff. We actually have machine learning AI helping us nowadays to just scan this and make it black and white, increase the contrast, remove smudges, automatically find the corners of the sheets. So all of that works in this case with Google Drive, but there's a lot of apps that implement this. An example that really amazes me is when we use the camera sensor to literally improve someone's eyesight. So in this case, I'm showing the Google Magnifier app, which helps people with visual difficulties to literally see better, because it allows zooming, it allows contrast enhancements, or it changes the color spectrum, all of that live. And finally, an inspiring use case is to help people navigate better with Google Maps by overlaying the camera stream with helpful navigation hints. I keep thinking about showing these use cases, the ones I showed you now, to someone in the 80s or 90s. And they would not believe all the things that we now take for granted. So I wanted to give you a little bit of an overview of these things we do with that camera sensor before I dive into how we can actually do them. Now, you might have a use case similar to those that I mentioned so far, or you might have actually thought of some innovative new way that you can use that sensor. Once you start coding, it can actually be difficult to choose what kind of implementation you need. And when you choose one, it might not actually immediately be clear how you can use Jetpack Compose to implement it, because a lot of the documentation as of today is still written for views. So today, my plan is to show you a range of typical use cases and their Compose implementation. So we'll touch upon a lot of different Compose things, not just the camera APIs, But I just want to make sure that, for all of those typical use cases, you know when you want to choose them and how you could implement them. Now, there's 4 different ready-made solutions that I want to discuss. First, I want to show how you can use an external camera app, so not implementing anything yourself, but launching an external app to take a picture. Second, we can use that same external camera app to record a video. Third, we can use a ready-made component to scan a QR or barcode, something that you do quite often in an app, but you don't actually have to implement this yourself. And fourth, we can use a component that helps the user scan a document. So not a QR code or barcode, but a document. All of this without any of your own implementation. So before going into those implementations, why would you choose a ready-made component over implementing your own? Well, one of the things is that when you choose a component that's provided by the Android system, you don't have to actually ask for the camera permission. So that annoying pop-up that you get that users have to accept to use the camera sensor is not needed because you're actually giving that access to another app and not to yours. So you don't need to deal with permissions at all. The user doesn't have to give up their privacy in your app, and so they're probably more likely to use this flow. It's easier to implement. As I said, a couple of lines of code, so why would you do your own? It's well tested. These components are components that are used by many, many developers, and therefore, they have gone through rigorous testing, and they've been standing the test of time as well. But if you find bugs, typically you're not the first one and not the only one to find them, and so typically there will be some issue in our issue tracker which you can vote for and which will hopefully be fixed by someone else than you, so you don't have to fix your own bugs, which is awesome. Of course, it's not all good, so when you build your own, it's more flexible, right? Like you have more capabilities of change, and if you have the time and if you have the people to do it, it's more powerful. Like you can build everything that you wish for and everything that you hope for. Another thing that I think is a benefit of when you implement your own camera stream in your app is that you're not breaking up the app flow. So you can use the same kind of theming, the same color schemes, etc., maybe the same top app bar or whatever your app is using, and everything can really be integrated well into your UI. And this is, I think, the main reason why we see a lot of apps still implementing their own, even though a ready-made implementation could theoretically work just as well. And of course, you're fully in control. Like you can, the bugs are your bugs, so you are also in control of fixing them, and you don't have to wait for a bug in an issue tracker that someone doesn't have time for. So it's a bit of you can go both ways. I think it's good that you start by thinking if you can use one of the ready-made implementations, and then if you decide that it's just not fitting your use case, you can always go back to do it yourself. But let's take a look at how easy they actually are. So I want to start with taking a picture with the external camera app. So let's see what happens. I have a button, I press take picture, camera starts, I didn't have to give a permission, take a picture, I say yes, and I can show the picture. Okay, that should be doable to implement, right? Okay, let's start with the dependency. If we want to launch an external task using Compose, we will need a method from the lifecycle library. So we need to add the lifecycle Compose library in this case. I'm using a version catalog here, so I'm not just showing implementation and then the name. This is the kind of recommended way of dealing with your dependencies in your app, but it's similar to what you would typically do. And it's using a version catalog helps you because it's an easy way to define library dependencies only once and then use them in all your different modules and all your different areas. Okay, so now we can implement this screen. So I called it take picture with camera app, pass the modifier as we do, and I defined 3 steps. So first we want to set the location where we want the image to be stored, because we're going to ask another app to store the image for us, and then we need to read it from that location. Like we cannot just have that app send us a huge bitmap, right? So what we do is we send it a URI, we ask, please save it to that URI, we get the URI back, and then we display what file is in that URI. Step 2 is define how to launch that external component. So how can we actually launch that camera taking experience? And the third step is showing the actual UI. So step number 1, I'm using the file provider here. That is because for privacy reasons, we cannot just give it a file path. Like 10 years ago, that's what you would do in Android. You would just say, you know, create a file URI directly and pass it. But that would mean that we need to give that app, that other app, permission to take a look at the files that are part of our app, which is a privacy concern. So file provider actually solves that for us because it creates kind of like a temporary content URI, which you can pass, and then the app can use that, and then we can actually have access to that same one. There's a bunch of more steps. I actually, when I was implementing this, it was the first time I was working with file provider. There's quite a lot of steps, so keep that in mind. But the file provider class itself, the reference docs explain really well what those steps are and how you need to implement them. So with that, we can go to the next step, step number 2, which is defining how to launch the external component. In this case, we can use the remember launcher for activity result method, and that's the one that's coming from that Android X activity compose library. So this is, makes it easy to launch specific components from within your composable tree. So normally you would have to go through an activity, from the activity launch an intent, etc., which is not really great if you're in Compose world, because you don't have a reference to your activity and you don't want to be creating that. But this actually makes this a lot easier. So it has a bunch of pre-made contracts. In this case, we're using the activity result contracts take picture, which basically creates for us the right intent, launches that intent using the activity for result APIs, and then gets the result and transfers that result to a Boolean that tells us if the capture was a success, yes or no. So we don't have to consider, we don't even have to create an intent, we don't have to do any of that fancy stuff. And with that, we can actually show the UI. So we create a box, and if the capture was a success, we show the image. We already had the URI. In this case, I'm using a null content description because I wouldn't know how to actually describe what's shown on this image. And then otherwise, I am showing a button, which is a button we saw in the beginning, that when you tap it, we take that launcher that we defined in step 2 and we launch the URI. And basically, that way we're telling the system that, hey, we want to create, we want to take a picture, and please return to us if that was a success, yes or no. So far, so good. Okay, this is a very basic understanding of what we just did. It's going to be more complicated with the next one. So if you understand this one, I'm super happy. We're going to now do a recording a video, which is going to be very similar, actually. Works very similar to taking a picture. So let's take a quick look at that one. We open up the video, record it, and then when we're done, in this case, I am not actually showing the video because I didn't want to get into the whole media player area, which is a whole different can of worms. But I'm just saying that, yes, we were successful. So how does that look? Same 3 steps, but step number 1, in this case, we are actually creating a URI for a file called video.mp4. So that's the only difference so far. We're creating a URI with a different ending. Then in our step number 2, works almost the same. The only difference here is that we use the activity result contracts capture video instead of taking picture. And then the only difference here, well, actually, I'm showing a text when I'm done, so I'm not showing the URI. So as you can see, this is very, very similar. So I want to quickly go to the next one. This is how we set it up, exactly the same as before. So how do we do this when we want to scan a QR code or barcode? Unfortunately, it's not as simple as those previous ones. We have to do a little bit more. So what does this look like? We start a scan. We get a beautifully Google-colored scanning environment, which automatically gives us the result of the scan. Okay, this is using something called the Google Code Scanner, which is part of the Play services. And it actually does that when you don't need a custom UI or you don't need a custom camera experience. This just magically works, which is quite cool, to be honest, on devices, of course, that have Google Play services installed. So how do we do that? Well, we add a dependency, in this case, on that code scanner. So we need to add that MLKit dependency. And then same 3 steps-ish, except for the fact that now we're not working with a URI or anything. In this case, we need to create a configured scanning client. But again, then we define how to launch it, and then we show the UI. So a lot of it is quite similar. So how do we create that scanning client? Well, we can add some options to it. So in this case, I'm creating a barcode scanner options object first, where we can enable auto zoom, allow manual input, stuff like that, defining which formats, like do we want QR codes only, barcodes only, etc. So you have quite a lot of configuration options here. And then with that, you can just retrieve that client. So not much exciting going on here, but I just wanted to show you that you can actually configure the experience a little bit, but you cannot configure the UI of it, for example. Then step number 2, how do you launch that external component? Well, in this case, we're not getting back a Boolean if taking a picture was successful. In this case, we're actually getting back a barcode, so an actual barcode. So in our case, we're creating a launch action, the thing that we want to do when we press the button in the beginning. And when that button is pressed, we want to start a scan. So we created the scanning client before, and on that scanning client, we can call start scan. And we can set listeners to that. So we can say, okay, if that was a success, we get the barcode back, but we can also deal with cancellation or failure if we want to. Maybe show a snack bar or show a toast or something like that. So with that, we know what we want to do when the button is pressed. The only thing that's left is actually doing that. And then, of course, when that barcode is retrieved, we can show the barcode content in our screen. Now, in a real app, you would probably not just show the result on screen. You would do something more fancy with it. Maybe you would forward it to your backend, or you do some business logic. But this is a very, very basic example of it. So this is how we do a barcode scan or a QR code scan. As you saw, this is like 20 lines of code or something, and that means you have all the functionality that you might want. So the next time in your app, if you're deciding, like, do we want that new feature where we need to be able to scan barcodes and do something with it, keep in mind that the UI part of it can be really, really short if you want to. So how does it look in our graph? Well, the only difference here is that we're saving a barcode value and that we're calling start scan instead of launching an intent through an activity. So with that, let's take a look at scanning a document. That's the one that's actually a bit more complicated and why I created all of those overviews in the first place. Because scanning a document has a little bit more of an API that I think doesn't play that well with Compose yet. But it's also in beta, so there is room for improvements, there's room for feedback. And I feel like that might actually, that API might actually be improved. Because what we want to do is we want to launch, similar to the QR code one, we just want to launch that experience and get the result and the information back. So how does that work? Let's take a look at where you can find all this information. As I said, it's in beta, so the API might change, but I want to show you what it looks like right now. Again, it's shipped with the Play services, so you don't have to incorporate it in your app. It doesn't have an impact on your app size. But you can just implement it with a couple of lines of code. So you add this dependency for kind of like interfacing with that Play services component. And then again, we have 3 steps, repeating the same thing. So if you just remember these 3 steps, you're fine. Step number 1, configuring. So again, we can create options, very, very similar. In this case, we can say if we want PDF, JPEG, or both. We can say what kind of scanner mode, so do we want all the fancy functionalities or do we want to just allow certain ones? How many pages do we want to scan, and do we want to allow people to import images from their gallery as well? So again, you have a bit of configuration options here, but you cannot change the color of the overlay or something like that. And with that, we have a scanning client. Then we create a local variable that holds the scanned result, and we create the launcher. Now we use the same pattern as we did previously, but we don't have a pre-configured activity contract to use here. So in this case, we need to convert the result ourselves. We can use the static from activity result intent to do so. And then we can basically get the data from the result of the intent, and then we can actually convert that back into an actual scan result. Now we also need a bit more manual steps for creating our launch action. So instead of being able to start a scan directly, we actually need to retrieve a start scan intent from our scanner client. And when that succeeds, in the onSuccess listener, that's where we actually create the intent sender request that we can launch. So this is a bit of a back and forth, and that's why I have a visual overview of this later. But if we have that all set up, then our UI implementation, again, is very similar to the previous one. We retrieve the data that we want to display from our scan results. If that data is not null, we display the PDF image and the page count. But if it is null, we show the button with that launch effect on it. So how does that look in our overview? So we start by getting an intent. Okay, we get the intent. With the intent, we can start the intent. That results in an activity result, and then we have to basically, from that activity result, convert that back into a scan result. So we have basically two steps here, a two-step process. And I think that's important to keep in mind, that it's a little bit more, it's like a little bit more steps than before. So that's 4 use cases that we just implemented with under 20 lines of code. Quite impressive, right? Like, I don't like coding, so I always try to code as little as possible, right? But of course, I know this is not always the way that we're doing things. So let's take a look at some do-it-yourself implementations. Now, we're going to implement our camera flow in 3 steps. We first have to deal with features and permissions. Then we want to take a look at configuring our cameras. And then we want to take a look at our UI. So let's start with features and permissions. This was not necessary in our ready-made implementations, but when you include camera in your app, you will have to indicate this, and you have to ask for a user's approval. So let's start by adapting our Android manifest. We add the user's permission tag to indicate that we'll request the camera permission at some point in our app flow. If we don't add anything else, by adding that user's permission tag, that will assume that the app can only run on devices that have a camera. So it's going to imply a lot of things, and all of a sudden, in the Play Store, for devices that don't have a camera, they will not see your app anymore. So to make sure that the app can be downloaded by the right devices, you have to consider basically the user's feature tag and decide which things are required and which things are not. In this case, I want the app to run on any type of device. I don't really care for now, whether it has a camera or not, so I explicitly set required to false for all of these different ones. But maybe in your case, I don't know, the autofocus is really, really necessary. Maybe in your case, you don't care if there's only a front-facing or only a back-facing camera. So you want to take a look at those, every one of them, and really make your own decision based on your use case. Now, to deal with the permissions at runtime, we're going to use one of the accompanist libraries. This takes care of a lot of the heavy lifting and makes it easier for you to deal with permissions. You might have used this before if you've used Compose, because anytime you run into permissions, this is one of the things you should be doing. Again, adding the dependency first. Then I'm creating my app. And the remember permission state is the one that's coming from that library. And I'm basically telling it that I'm interested in the camera permission. Now, if I want to record a video with audio, this is where I would also add audio, for example. And then basically what that gives us is a permission state instance. And that state that will change in a compose nice way. So whenever that state changes, we recompose this composable, and we will be able to do that if-else statement again. So we start by checking if the status is granted, and if not, we want to show a permission screen that asks the user to please accept this permission. Okay, so what does that permission screen look like? Well, we get that permission state, and we want to show some text that explains why we want this permission. This is the best practice. I got this straight from the accompanist example. But it's important to keep in mind that you cannot just show that pop-up. It's not a best practice, and Play Store will not like it. So you want to show some sort of rationale. And when the button is pressed, the button that says request permission here at the bottom, that's when we can launch the permission request. So with that, we have our permissions, we have our uses feature set up, so we can go to the configuration of the camera. Now, this is where we get into the big question of camera X or camera 2. And I tried both camera X and camera 2, and I can tell you that if at all possible, consider camera X. But I wanted to explain to you a little bit of what it actually is and what the difference is. So if you're working with your app code and you are using camera X, then you're actually also using camera 2 under the hood. So camera X is a wrapper, is kind of like an abstraction layer on top of camera 2. So where camera 2 basically directly talks to physical camera sensors and you have a lot of direct access, camera X abstracts that all away into a way that it's much easier to reason about. But if in your case you need access to that low-level stuff, you can choose to be in control and to directly interface with camera 2. So what are the reasons why you would choose one over the other? Well, as I said, camera X is much easier to reason about, but also it handles device quirks, and I think this is one that is really hard to underestimate how important it is, but it has this whole suite of possible device quirks that can happen. And with device quirks, I mean stuff like, I don't know, this specific device that was sold in 2018, whatever, it has the pixels all set 1 pixel to the left or something, that like from what is reported from the camera sensor. Or this one device or this set of devices from that period did their flash a second too late. So if you take a picture with a flash, you won't get an actual flashed picture. And so it has a whole suite, this is all open source, you can look them up, of dealing with all those device quirks and making sure that you get one consistent way of working with the camera. So when you deal with the camera X API, all of that is underneath the hood and you don't have to worry about that. And all of that is tested in a special lab as well. Like there's an actual physical lab that has all of those devices physically hanging and like taking pictures all day long, which I think is epic that that exists. But that's because we know that Android is such a diverse ecosystem, and we want to take that pain away from the developer and kind of like create one API that works for every device. Finally, bugs are not your bugs, same thing. If there is a bug with one specific device, or if there's a bug with all of the devices, I hope not, you can raise that bug in our issue tracker and it will be dealt with at some point. Now with camera 2, you do have direct access to the camera, so it's in that sense more powerful. You can create lower level abstraction interfacing, which in some cases makes more sense. Sometimes that kind of abstraction that camera X gives you is not what you need for your specific low-level use case. One other thing that we've seen happen sometimes is that because camera X is an abstraction on top of camera 2, that means that the moment a feature lands in camera 2, it still needs to land in camera X. Like there is a certain delay and we aim to have that delay as short as possible, but of course it is possible. So if your app is always on the verge of, you know, the front-facing first one to implement things, that might be an indication that you could do it directly in camera 2. And of course you're fully in control of everything. But yeah, as I said, camera X is really the one that you will most easily understand, and especially if you just have a use case in your app, so it's not the core of your app, you definitely want to look at camera X. But we've also seen big apps out in the wild use camera X to do quite core use cases with them. One example is YouTube Shorts. Everything that you saw in the beginning, it's all using camera X. So how does camera X work? It works based on use cases. So you define what you want your specific camera flow to do. So do you want to preview what the camera sensor is seeing at any given point in time on your UI? Do you want to analyze images? So you want to basically look at things and then analyze the frames that are coming in? Or do you want to capture an image or maybe capture a video? You can combine these into use case groups. So with one use case group you can say, please, camera X, start up the cameras and do your magic, but this is the type of things I will be doing with it. And when I define an image capture, for example, I can call take picture with it, and then everything will just work. So with that, let's implement that configuration. So again, we need to add some dependencies. In this case, I'm adding the minimum dependencies that you need to get a running app. You need to define the camera 2 interop, so kind of like the interface between that camera X and camera 2. And you need to define the lifecycle camera library, which gives you access to basically binding the camera's lifecycle to your app's lifecycle, because those two are quite intricate in their interaction. And with those two, like, they have some transitive dependencies, so in the end you get all of the camera stuff that you need if you want to implement some basic use cases. So I'm implementing here a preview use case. Again, I could be doing a lot of configuration here, so I'm not adding all of the options here to not overwhelm you. But that's the point where you can say for image capture, for example, you can say I want it to take the image in Ultra HDR. Or for preview, I don't even know, you can say the target frame rate of your preview stream. So again, you can configure those use cases, and then you build a use case group with them. And that's how you configure kind of what you want to do with your app. So let's go to the UI. How do we implement the UI? And this is where the most Compose comes into action, of course. So this is my favorite part. When we look at a typical camera preview screen, we can break up the UI into two parts. On the one hand, we have a layer with UI controls, and on the other hand, we have a surface that our camera stream is rendered to. Now, for the UI controls, they work in a similar fashion to any Compose UI. We pass events into our view model, and then state is being passed back to the composable that then can render it. Possible events here are capturing an image when pressing the capture button, or toggling the flash or auto capture states when tapping those respective buttons. The state describes what state the UI is currently in, and whether the flash and auto capture state features are currently turned on. So the UI controls can be rendered correctly. As this is just a normal back and forth pattern of UI and view model, I'm not going to show this implementation because it's going to be quite a lot of lines of code, but it's just the basic kind of like UI passing events, state being passed back in order to update what you're seeing. In contrast, when we're rendering the actual camera stream to a surface, it's a bit more complicated. There is no UI state as such that causes recompositions and re-rendering of the Compose UI. Instead, a surface will be rendered to directly by the camera library code. So we can envision this as delegating some of the state rendering from basically the camera controller to the surface. So instead of having just that view model and the composable interacting with each other, we have events going to the camera controller and the camera controller passing state to a surface. And that state is the actual rendering. And that goes outside of that whole Compose idea of the UI that re-renders based on recompositions, based on state changes, etc. This is just a very low-level rendering to a surface in your UI. It doesn't go through the normal UI tree. So there's multiple ways that we can set this up. So I want to take a look at two different ways. First of all, we can use, in the view world, we can use a camera controller class that is part of the camera view library. And we link it to the preview view. You might have, if you've ever done Camera X, might remember the preview view. Both the camera controller and the preview view are part of the Camera X library. And when those two are linked, the camera controller can request a surface, which the preview view can then provide. So they are basically just happily married together. Both of them always exist. And they can pass that surface, and they can render to that surface. Now, both the controller and the view can kill or restart the surface at any point in time. So that's how the life cycles of those two can be matched up. And the controller is responsible for rendering the preview stream. So how would we implement this version? Well, first, we add a dependency, in this case, camera view. And I wanted to show kind of what our current recommended way of implementing this is, because we can do everything in the UI, and that's the most basic implementation, and that's the implementation that you will see in like the basic tutorial, etc. So I wanted to do one little step on top of that, and that is extracting that camera controller from your UI. Because maybe you want your camera controller to be influenced by other things, by your business logic, or maybe you want to do a network call and based on the result want to update what the camera controller is doing. So ideally in an ideal architecture, that camera controller is something that doesn't live in your UI. And so what I'm doing here is I'm actually using Hilt to install a lifecycle camera controller inside the view model component. So I'm basically saying a view model can request such a controller, such a camera controller, and at that point it will be instantiated and it will stay alive together with that view model instance. So every view model will get a different instance. And then in our view model, we can actually, inject that camera controller in the constructor. And then instead of binding our camera controller to our app lifecycle, we can attach it to our coroutine lifecycle. Now, this is a bit of a weird one to wrap your head around, but I really wanted to show it because I think this is the direction that we're taking the camera library in. So we are making iterations on this and we are adding APIs at the moment in the library. And one of that is to kind of take that controlling of the camera away from the UI into our business logic and bind it not to our UI and to our apps lifecycle, but bind it to a coroutine lifecycle. And then that coroutine lifecycle can be started or cancelled from the UI by events. So in this case, I'm creating a camera job by launching, so the moment the start camera method is called from within our UI, we basically launch in the view model scope a new coroutine. And in it, we bind the camera controller to a lifecycle, but we don't bind it to an activity lifecycle, which has a resume and a pause and all those things. We're binding it to a coroutine lifecycle owner. And that basically is just, when the coroutine is cancelled, it pretends to be destroyed. And when the coroutine is started, it pretends to go to the start state. Now, I know this is a lot, so if you're not that versed in coroutines, you can ignore this a little bit. But it helps to set up a strong architecture when you're dealing with the camera. And then when you're stopping the camera, the only thing you need to do is actually canceling that coroutine. So what does that do with our UI? In our UI, what happens is we create a lifecycle start effect, which is tied to our activity lifecycle, but now we've really extracted those two things. So when the lifecycle is started, it calls start camera, and when the lifecycle is stopped or we dispose this composable, we stop the camera again. And then the only thing we need to do is wrap the preview view and set the camera controller to the camera controller that we created in the view model. Now I know that I said that I was going to do Compose, and I know that I'm showing an Android view here, which is not really Compose, so I'm aware of that. And we are working on this. So yes, this works, but it's using view-based APIs, and for complicated scenarios that actually becomes quite difficult to deal with. And in addition, camera controller and preview view are huge files with a lot of logic, and that logic is both about life cycles, but it's also about how they interact with each other, and there's a lot happening there, which isn't really playing nicely with Compose. So we have been working on a Compose native solution for camera. With the viewfinder Compose artifact at the top, currently in snapshots, and I'm going to hope soon in alpha, we are trying to break apart the UI logic from the camera logic. So as I was saying already a little bit with extracting that camera controller, we're taking that a step forward, and we want to make it more component-based. So here we don't link the UI to a camera controller. Instead, when the preview use case is ready to start rendering the camera stream, it requests the surface using a surface request instance. That surface request instance is forwarded to the viewfinder, which then starts up a surface and fulfills the request, thereby giving the preview use case access to that surface that it can render to. So this is similar to the thing we discussed before, but instead of just drawing a line and attaching a viewfinder to a preview, here what we're doing is we're creating a lambda, which is a service request, and we're, based on that, returning a service that can be rendered to. Now, I understand this is a lot to wrap your head around. Don't worry if you didn't fully grasp this. I think The important bit to remember is setting up the UI for camera streaming to a surface is very tricky. Those life cycles interact in complicated ways, and we're currently trying to help you by coming up with better APIs and opinionated guidance. So should you wrap preview view or use this new Compose viewfinder artifact? Well, I mean, the preview view is the stable one, so for now, yes, that's what you want to do. It contains many features, but it only works with Camera X. So if you were going to use Camera 2, you're actually in a bit of trouble and you would have to implement your own thing. And as I said, it's built for views, doesn't always play nice with Compose. Now the viewfinder artifact's under active development, and we're working towards that alpha. It uses a lower level abstraction, which can be difficult to deal with when you just start with it. But it does work with both Camera 2 and Camera X, and we're going to be building more abstraction on top of it. So although it's not ready for production yet, I would ask you, please try it out and give us feedback on it. And with that, I think it's time that we start rounding off. We discussed many different camera experiences, and I tried to give answers to these questions on screen. Some resources, if you want to see a modern way of implementing a camera app, which includes all of these best practices, I'd forward you to the Jetpack camera app sample. This is an app that is written by our Camera X engineering team, so it's not written by DevRel, as a reference sample for testing camera features. So we use it basically to test if new camera features work well on all the different Android devices. But what it does have is it has the latest implementation of the Compose viewfinder artifact. It also adheres to all of the Android architecture guidelines that we're setting up, and we're in active communication with this team that's building it to make sure that this can be a good example of how to use architecture in a camera app. So take a look at it, take a look at what's happening. There's still a lot of active development happening here, but it's good to check it out. And this is also how you can find that new viewfinder artifact. Then all the code that we use today, I uploaded it to a gist. So if you go to my profile on GitHub, you'll be able to click through to all of these snippets. And I wanted to call out the office hours that a bunch of us are doing, not just about camera, but you can come with camera questions, but everything Compose related. 4:15 p.m. in the Dev Lounge. 4 of us are going to be there to answer your questions. And with that, I hope you learned something today. Thank you so much for your attention. There's